those two. So, and the interesting thing, they said, it's really easy, if you consider it a half a metre, it's really easy for them to fire an electron and get it to go through the hole at the end of that. It's relatively difficult to get it to go through the hole at the end of 3 kilometres. And it's amazing, as you get that increase in velocity, the accuracy of this device gets better the higher the velocity of the object goes, which does my head in, but that's a whole lot of what this relativity is all about. Okay, so a couple of check your understanding questions here. Particles travelling in the Earth's atmosphere at a speed of 0.75 the speed of light. To the earthbound observer, the distance it travels is 2.5 kilometres. How far does this particle travel in the particles frame of reference? So we know we're observing that, it's travelling at 0.75. What actually happens to the length, so the 2.5 metres that we measure travelling at that speed, what does the particle actually see? So you would go through, substitute into here, that'll tell you the conversion factor, and then you divide by the conversion factor, and that will show you how much the length should be reduced. All right, is that reasonable? And it drops down to 1.65 kilometres. So even travelling at 0.75 the speed of light, which is still pretty rapid, is enough to have that much an effect on the distance the actual particle travels. All right, any questions around that little bit? Because there's 3 conceptual questions now that you can work through, and then there's some problems as well, and the solutions are included. Yes? No? Any questions? All good? Good. You're done?